the human immune system, invisible warfare inside us as we understand it. Earth is one of the most carefully defended systems we know, not by walls, or weapons, but by something far more complex, a living network of cells, signals, and biological intelligence that works silently every second of your existence. A system so fast, so layered, and so coordinated that most of the time you never even notice it is there. But what if that system failed? What if, right now, inside your body, invisible invaders were already trying to take control and a full-scale war was already underway? This is not science fiction. This is the story of the human immune system, invisible warfare inside us as we understand it. Every second, your body is exposed to threats. Bacteria, viruses, toxins, and microscopic organisms attempting to enter, survive, and replicate. And yet, most of the time, you remain perfectly unaware. That is because the first line of defense is already active before anything even gets close. It begins at the surface. Your skin barrier protection is not just a covering, it is a living shield. Thick layers of specialized cells form a physical blockade against intrusion. But the skin is more than structure. It is chemically active. The sebaceous glands produce sebum, an oily substance that coats the surface, forming a layer of antimicrobial skin defense. This sebum doesn't just protect against drying, it actively discourages microbial overgrowth, helping maintain a stable microbiome balance, where skin microbes live in symbiosis, competing with harmful invaders and keeping each other in check. Even here, at the edge of your body, warfare is already happening, silent, balanced, and constant. But not all threats stop at the surface. At every entry point, your nose, mouth, and respiratory tract, another defense system begins: mucous membranes. These moist biological barriers trap particles, bacteria, and viruses before they can go deeper. And embedded within them are microscopic structures called cilia, constantly performing cilia movement coordinated waves. This motion drives mucociliary clearance, pushing trapped debris upward and out of the airways. If this system is overwhelmed, your body escalates the response. The coughing reflex activates, a sudden, forceful expulsion designed to eject intruders from the lungs and trachea before they can establish infection. It is a mechanical emergency protocol. 5 triggered instantly when chemical and cellular defenses are not enough. But if something still gets through, the real war begins. Deep inside your bones lies the origin of the entire defense force. The bone marrow is where hematopoiesis takes place, the continuous blood cell formation process that produces all immune cells. Here, hematopoietic stem cells divide into progenitor cells, forming the raw foundation of your immune army. From this biological factory emerge leukocytes, or white blood cells, the soldiers of your internal defense system. Among the first responders are neutrophils, fast-moving, short-lived, 0.5, and highly aggressive. They are part of the innate immune system, the ancient immediate response branch of immunity that reacts within minutes, not days. When tissue is damaged or infected, inflammation response begins. Blood vessels, lined with specialized endothelial cells, become activated. 5 chemical signals, cytokines, the language of immune communication, flood the area. These cytokines guide neutrophils using chemotaxis, a process where cells literally follow chemical trails like heat-seeking trackers. To reach the battlefield, neutrophils must exit the bloodstream. They attach weakly at first to the blood vessels, then form stronger bonds before squeezing through the vessel wall in a process called diapedesis. It is cellular migration under emergency conditions. Once inside the infected tissue, they encounter the enemy. Bacteria multiply rapidly, releasing toxins and damaging surrounding cells. The neutrophils respond with phagocytosis, engulfing pathogens, breaking them down, and destroying them internally. It is not negotiation, it is immediate elimination. At the same time, macrophages arrive, larger, more experienced immune cells that not only consume pathogens but also orchestrate the battlefield. They release signaling molecules, including tumor necrosis factor, TNF, which amplifies inflammation, increases immune cell recruitment. 45 raises body temperature through fever induction, and boosts leukocyte production overall. TNF is not subtle, it is a system-wide alarm signal. But innate immunity is only the beginning. If the infection persists, the adaptive immune system activates, a slower but far more precise response. Inside lymph nodes and the spleen, immune cells gather and coordinate. Dendritic cells, acting as antigen-presenting cells, APCs, capture fragments of pathogens and display them on their surface like biological evidence. These antigens are then scanned by naive T cells, which circulate through lymphatic tissues, searching for their matching target. These T cells were originally trained in the thymus, where T cell maturation ensures they can recognize threats without attacking the body itself. When a T cell finally recognizes its specific antigen, antigen recognition triggers T cell activation. The cell awakens, and then something extraordinary begins: clonal expansion. One cell becomes thousands. A targeted army is produced in response to a single invader. Some of these become cytotoxic T cells, also known as killer T cells. Their role is direct elimination. When they detect infected cells displaying the correct antigen, they induce apoptosis, programmed cell death. The infected cell is dismantled cleanly, preventing further spread of the pathogen. Other T cells become helper T cells, coordinating immune responses, activating other immune cells, and amplifying the system's precision. Regulatory T cells ensure the response does not spiral out of control, maintaining balance and preventing damage to healthy tissue. Meanwhile, memory T cells remain long after the infection is gone, ready for faster response if the same pathogen returns. This is immune surveillance, a living memory of past battles. B cells operate in parallel, forming the antibody production system. Once activated, they differentiate into plasma cells and plasmablasts, specialized factories that release antibodies, also known as immunoglobulins, into the bloodstream. These antibodies bind specifically to antigens through antigen binding, neutralizing toxins, and marking pathogens for destruction. This tagging process, called opsonization, makes it easier for macrophages and neutrophils to recognize and eliminate threats efficiently. When the same pathogen returns, the secondary immune response is faster, stronger, and more efficient, a biological memory system refined by evolution. But not all immune defense is cellular combat. Natural killer cells patrol the body, identifying abnormal cells, including virus-infected or cancerous cells, and eliminating them without prior sensitization. Platelets, or thrombocytes, derived from megakaryocytes in the bone marrow, initiate thrombopoiesis and play a completely different but equally vital role. When blood vessels are damaged, hemostasis begins. Platelets rush to the injury site, forming a platelet plug formation. This is reinforced by the blood clotting cascade, producing fibrin network formation, which stabilizes the clot and seals the wound. Over time, this structure supports wound healing, restoring tissue integrity and preventing blood loss. What emerges is not a single system, but a layered defense architecture. Innate immunity responds instantly. Adaptive immunity learns, remembers, and improves. Barrier systems protect the outside world from ever entering. Chemical signals coordinate billions of cells in real time. This is not just biology, it is a constantly active war simulation, running silently inside you every moment of your life. A system that identifies threats, coordinates responses, eliminates invaders, repairs damage, and remembers every encounter. And yet, despite its complexity, it rarely fails, because it is not designed for perfection in stillness, but for survival under constant pressure. Right now, as you read this, your immune system is scanning, detecting, responding, and adapting not once, but everywhere, all at once. An invisible war that has never stopped since the day you were born. And if you found this journey through the human immune system fascinating, stay connected for more deep dives into the hidden systems that keep life itself running. If you found this fascinating, don't forget to like, subscribe, and stay connected for more journeys into the hidden systems of life.